So from the picture, I could tell the vertical displacement is 150 minus 144, since the tape measure starts at 150. So that equals 0.06. And the horizontal displacement is 150 minus 34, or 1.16 meters. So using the Pythagorean theorem, I could get the displacement of the ball. So 0.06 squared plus 1.16 squared equals displacement squared. So solving for displacement, I would get 1.16155 meters. The time, as shown from the video, is the absolute value between the starting time of 21.141 minus the ending, which is 25.725, and that equals 3.584 seconds. As we know, initial velocity equals 0, since the ball was not moving. And the formula I will use is delta D equals 1/2 bracket VI plus final velocity times T. Subbing in the numbers, I would have 1.16155 equals 0.5 times 0 plus final velocity, which is what we're trying to get, multiplied by 3.584. In solving for velocity final, I would get 0.65 meters per second forward. So to be able to find work done by the billiard ball, we'll first need to find acceleration. So these are the numbers from the previous question, and the new formula we will use is delta D equals VI times T squared over 2. Plugging in the numbers, I have 1.16155 equals 0 plus acceleration times 3.584 squared over 2. In solving for A, I would get 0.18136 meters per squared forward. So now the work formula, as we know, is work equals force times distance. We know distance is here, so it's work times F times 1.16155. So now we really need to find force, and we'll find that using Newton's second law, which is force equals mass times acceleration. So the mass of the billiard ball is 0.17 kilograms, which is standard for all billiard balls. So I'll use that number. So force equals 0.17 times 0.18136, which equals, let me figure it out, 0.17 times 0.18136. Which equals 0.0308. So I multiply that with my displacement, and I would get total work equals 0.036 joules. So from the picture, you can see that the ball leaves the pipe at 25 centimeters off the ground, and it hits the photo frame 15 centimeters off the ground, and the horizontal displacement is 29 centimeters from the picture. So now I can redraw this, since the real vertical displacement was actually 10 centimeters, since it dropped from 25 to 15. So I drew it like that. And to find the velocity of both the horizontal and the vertical, I will be using this formula. Velocity equals distance over time. Time being the absolute difference between the starting time of 14.401 minus the ending, which is 14.655, which I got from the video, which equals 0.254. So first, the velocity of y, or the vertical, is 0.1 divided by 0.254, which equals that. And for the horizontal velocity, average velocity, is 0.29 divided by 0.254, which equals that. And then to find the total average velocity of the ball, I will be using the Pythagorean theorem and plugging in the numbers for the velocity of y and the velocity of x, as you can see here, and I end up with the average velocity of the ball being 1.21 meters per second forward. So from the picture, the height of the ramp is 1 and the length is 30 centimeters. So using tan, I'm able to find theta which comes out to be 1.9092 degrees. Now I need theta because for inclined planes, the normal force formula is actually mass times gravity times cos theta. So plugging in the numbers I have, I get the normal force to be 0.0328. So now the coefficient of static friction for glass on wood is 0.2, as I got from Google. So the full formula for the force of static friction is the normal force times the coefficient of static friction, which comes out to be 0.0328 times 0.2, which ends up equaling 0.0066 newtons. And that is the force of static friction.